Recall that the form for a linear regression model is y hat equals a plus bx, where y hat represents a predicted value that would correspond to a given x value. A represents the y-intercept of the model, and b represents the slope coefficient. We also need to note that at times you might see a linear regression model given using a little bit different notation, where b sub 0 would represent the y-intercept and b1 would represent the slope coefficient. And that's because sometimes you would include more variables in your linear regression model, and it would be called a multiple regression. So you'd have a b0, a b1, a b2, a b3, and you'd have an x1, an x2, an x3, and on out like this. But for this simple linear regression model that we're looking at, where we only have the variable x and the variable y, the slope coefficient can be calculated using this formula: r, the correlation coefficient, times the standard deviation of the y values divided by the standard deviation of the x values. And then the y-intercept, a, can be calculated by this formula: the mean of the y's minus the slope coefficient that we will have just calculated, b, times the mean of the x values. Sometimes on the AP exam you will find a problem where you are given these values and you are to use these formulas to calculate this regression model. So here we have an example where the mean for the x values is 50, the standard deviation is 10, the mean for the y values is 75, the standard deviation is 20, and the r value is 0.8. So in order to find the slope coefficient, we would say, okay, b is equal to r 0.8 times this ratio of the standard deviation of the y values to the standard deviation of the x values, 20 over 10. And so b then is going to be 1.6. And then to calculate a, we'll use this formula: a equal to the mean of the y values, so 75, minus the slope coefficient, 1.6, times the mean of the x values, 50. And so a will then be equal to minus 5. So this model then would be given this way: y hat, the values that would be predicted for the y variable, would be equal to a minus 5 plus b 1.6 times x. It should be noted that usually the y-intercept by itself really doesn't have any meaning, because a linear regression model is only good for the range of values spanned by the data. Suppose for a moment that this data set contained only positive values, yet we have a y-intercept of minus 5, which would be outside of the range of those values. And so therefore that y-intercept would really not have any meaning relative to the data set. Let's look at example 2. Our slope coefficient b would be calculated by multiplying r, which is minus 0.75, times the standard deviation for the y values, 1.5, divided by the standard deviation for the x values, 2.5. And b is then going to be minus 0.45. The y-intercept, a, will be calculated starting with the mean for the y values, 80, and then subtracting from that b, which was minus 0.45, times the mean of the x values, 30. And a then turns out to be 93.5. So the linear regression model then for this particular example would be y hat equal to 93.5 minus 0.45x. One more thing to note here. In this model, the slope coefficient is negative, and so is r. And that's not a coincidence. That should be the way it is. If r is negative, it implies that as x increases, y would decrease, which is what would happen in a linear expression like this. Notice here that the slope coefficient is positive, and here the r value is positive. Positive r values imply that as x increases, so would y, which is what would happen as x increases in a linear model like this.